In this video, we're going to be talking about how to find the slope between 2 points, and then later on how we can use that slope to determine if we have two lines that are parallel or two lines that are perpendicular. So first, let's define slope. Slope in its most basic sense is the steepness of a line between 2 points. It is represented by describing a ratio. A ratio is anytime we compare two things. So the two things we're comparing in the slope ratio is the vertical change compared to the horizontal change. So we'll talk about that when we actually see an example of 2 points. A lot of times in real life we may see slope represented as a percent, such as a road sign that looks like that. All they did is they took that ratio, turned it into a decimal, and then converted it to a percent. So it is the slope, but just in a percent form. A lot of times, though, we're used to slope in algebra, which is represented by discussing what's called a rate of change. So we'll hint at that, but in this video and in our class in particular, we're talking about slope as the incline or decline or the steepness of a line. So real quick, just to touch on what it looks like algebraically, because for the most part in math classes you talk about slope as a rate of change. In this example, if we want to know the total cost of X amount of pizzas, if they each cost $5, we can represent that as an equation that says Y, being the total cost, equals 5 times X, the number of pizzas, which means that our total cost is changing by 5 for every pizza that we have. So y equals 5x would be the equation to get the total cost, with the number 5 representing our slope or our rate of change there. Lots of ways that we can represent slope. We can use the variable m. We can write it as a ratio, which we talked about. We can say it's rise over run, or delta y over delta x, which essentially means the change in y over the change in x, which is the same as rise over run. And that's all represented by subtracting. So to find the change in y, we're going to find the difference between our y coordinates. We're going to subtract. And the change of x is going to be represented by subtracting to find the difference between your two x values. So we have our height change on top compared to our horizontal change on the bottom. Let's practice using that equation. Anytime we find the slope between 2 points, we could have 4 possible outcomes. We could have a representation of 4 different types of lines if we pretend that the 2 points could be connected by a segment or a line. So if we plot A and we plot B here on our coordinate plane, we can visualize the type of line or segment between those 2 points. We can see that it is going up, or as we tend to describe it, it's increasing. To find our change in y, or the change in our height there, we're going to subtract our two y values. Let's start with our b y value and subtract the a y value. So 7 minus 2, that'll give us 5. To find our horizontal change, or the difference in our x values, we're going to subtract our x values here. So we're going to do 3 minus negative 5 on the bottom. Be careful, a common mistake is to see a negative number there, but then see subtraction and only write 1 minus sign. Do not write 3 minus 5, that's not the same. Always subtract your coordinates and subtract the values that you see. So sometimes we do have double negatives. In this case we got 3 minus negative 5. Anytime you have double negatives next to each other, pretend that that's a positive, it becomes positive. So this is really 3 plus 5 on the bottom, which becomes 8. So we have a horizontal change of 8 compared to a vertical change of 5. We write the slope as the change in y over the change in x, or 5 to 8. So anytime you see a positive slope, you know that the line between those 2 points is going to be increasing. Or anytime you see an increasing line, you know that its slope value is going to be positive. Use that as a mental check. So for example, don't tell me that the slope of this is negative, or if you've got a positive slope, make sure that you're not drawing a line that's decreasing or going down from left to right. And number 2, we got our second possible outcome. This time between our 2 points we have what's called a decreasing line. So we should get a negative slope value. Let's see what happens when we evaluate it. We're going to find our change in y. So let's subtract the by value and take away the ay value. So 2 minus 4. Then to find our change in x, again, take our xb value and subtract our xa value there. So 0 minus negative 6. So on top we have 2 minus 4, which is negative 2, and on the bottom we have 0 minus negative 6, which turns into 0 plus 6. Here we have negative 2 compared to 6. Since slope is a ratio, we always reduce our ratios. So let's divide top and bottom by 2 and get negative 1 to 3. So while it is true that from A to B we're going down 2, right 6, it is also true that we're just going down 1, right 3 a bunch of times. So again, a decreasing line will have a negative slope. Increasing lines will have positive slopes. Let's check out 2 special cases here. For number 3, if we plot our 2 points, we see a straight line. It's flat. We call this a horizontal line. It looks like the horizon. Let's find our slope and determine what the slope of a horizontal line is. So we're going to do 4 minus 4 on top, subtract your y values. On the bottom we're going to do 5 minus negative 3, which is going to turn into 5 plus 3. Notice that on top we have the same y values, which means that when we subtract them we're going to get a result of 0. And 0 divided by anything is going to equal 0. So for horizontal lines, don't leave your slope as a ratio. Take it all the way to the 0 form and say the slope is 0 or none. Maybe you can take a shortcut as you practice this a bunch, and anytime you're given 2 pairs of points, if you notice that the y values are the same, you know that this is going to be a horizontal line. It doesn't matter how long the line is, so it doesn't matter what our change in x is. It's going to be 0 divided by that number anyways, and it's going to be 0. So if you know that the y values are the same in your coordinates, you should automatically know that you have a horizontal line with a 0 slope. So the reason it has a 0 slope, slope is talking about an incline or a decline of some value. This has neither, it's flat, so we have a 0 slope. Our last example here, last special case. When we plot these 2 points, notice that we have what's called a vertical line, just straight up and down. Vertical lines don't have any run or any horizontal change, so they can't have a slope. So what we say is that vertical lines have an undefined slope. And the reason it's undefined, if we try and calculate it using our formula, on the top we're going to subtract our y values, negative 3 minus 8. And on the bottom we're going to subtract our x values, 5 minus 5. Notice now that the bottom values or the x values are the same in the 2 coordinates. If we subtract them we get a value of 0. And since 0 is in the bottom or the denominator of our ratio, that's represented using division. So negative 11 divided by 0 is an error on your calculator if you try it. And we say it's an undefined slope. We can shorten that to UND. So again, anytime you're looking at 2 coordinates and trying to find the slope between them, if you notice that the x values are the same, that means there's no horizontal change. That's going to be a vertical line with an undefined slope. All right, now that we know how to find slope between 2 points, let's take it a step further and establish what slopes of parallel lines look like. In this example, we're given 2 pairs of points. So points A and B are going to represent line AB, and points C and D are going to represent line CD. If we plot them, we see that they look parallel, but in this unit we're going to try and go a little bit further. Rather than just saying they look like they're parallel, we're going to use their slopes to prove that they're parallel. So if we find the slope of line AB, we're going to subtract the y values here, 2 minus 5 on top, And on the bottom, subtract the x values, negative 3 minus 2. On top, 2 minus 5 is negative 3. And on the bottom, negative 3 minus 2 is negative 5. In some cases, we get negatives on top and bottom. That's a negative divided by a negative, which we know simplifies to a positive. So make sure you take it to that last step and make it positive. That makes sense. We got an increasing line and a positive slope. Let's try to do the same thing with C and D. Subtract the y values. 2 minus negative 4, that's 2 plus 4, which is 6. On the bottom, subtracting the x values. 8 minus negative 2, that turns into 8 plus 2, which is 10. We have 6 to 10. We know that we can reduce that ratio by dividing top and bottom by 2 and get 3 to 5. So always reduce your ratio, because it may happen that you look at 3 to 5 compared to 6 to 10 and you think they're not the same. Make sure that you simplify so that when you compare, it becomes real clear that we have the exact same slope. And that's what's true about parallel lines. Parallel lines have the exact same slope or equal slopes. That's what helps them stay parallel and never intersect, because they are behaving the exact same way. In this second example here, how do we prove that two lines are parallel? Well, we just talked about how we could compare their slopes. So later on in this unit, we're going to have to compare two lines and prove that they're parallel. So the way that we do that is we pick 2 points off the line that are easy to find, and we find the slope between them. So for this top line, I'm going to call it line 1. I'm going to pick these 2 points right on the axis. Those are easy to use. So this is 0, 2. This is negative 3, 0. If I subtract my y values, 2 minus 0, I get 2. And if I subtract my x values, 0 minus negative 3 is 0 plus 3, so that becomes positive 3. So my slope is up 2, right 3. Positive slope, increasing line, that makes sense. This line below, I'm going to call line 2. I'm going to pick these 2 points, and I'm going to find the slope between them. So subtract the y values. 1 minus negative 3 is 1 plus 3, which is 4. And subtracting the x values, 3 minus negative 3 turns into 3 plus 3, which is 6. 4 to 6 can be reduced by dividing top and bottom by 2, and we get 2 to 3. So comparing the two slopes, we see that they're equal. We now have guaranteed and proven that these two lines are indeed parallel. One more example, very similar to what we just did, except we're going to look at perpendicular lines and compare their slopes. Plotting points A and B and connecting them to draw a line AB. And plotting C and D and connecting to draw a line CD gives us this result. They look perpendicular, but let's make sure and prove it. Let's see how perpendicular lines and their slopes compare. Find the slope of line AB. Subtract your y values. Negative 5 minus 2 is going to be negative 7. Subtracting the x values, negative 2 minus 3 is negative 5. I have a negative divided by a negative, so take it one more step and make it positive. So line AB is increasing. It has a positive slope. Seem to be good there. Taking a look at line CD, it's decreasing, so let's make sure we get a negative slope value. Subtracting the y values, we have negative 3 minus 7, which is negative 10. And subtracting the x values, we have 10 minus negative 4. That turns into 10 plus 4, which is 14. Negative 10 compared to 14 can be reduced. Let's divide top and bottom by 2 and get negative 5 to 7. Now, comparing the slopes, not the same as parallel lines because they do intersect. One's going to be positive, one's going to be negative. That's going to help them intersect. In math, we say that numbers that are the same but are positive or negative are called opposite values. So if one is positive and one is negative, they're opposites. That's going to be half the definition. The other half, if you notice, is that they are both fractions that are flipped from one another. So this is 7 over 5, and this is 5 over 7. In math, we call those reciprocals, fractions that are flipped. So these two slopes are both opposite and reciprocals of each other. So when we have lines that are perpendicular, their slopes will look like opposites and reciprocals. One other thing that's true about perpendicular slopes is that you can multiply their slopes and the result will always give you -1. However, the only special case where that is not true is if you try and do that with just basic horizontal and vertical lines. Horizontal and vertical lines are going to be perpendicular, but we can't multiply their slopes. We can't multiply by an undefined value, and we can't multiply by 0 to get -1. So those special cases will not work with this property. However, all other cases, the product of perpendicular slopes will equal -1. Not necessary, of course, if you can just compare and look at the slopes and tell that they're opposite and reciprocals from one another. All right, one more time. Let's see if we can prove that these two lines are perpendicular by comparing their slopes. So while they do look perpendicular, they might be slightly off. Let's make sure. I'm going to call this decreasing line line 1, and I'm going to choose these 2 points to find the slope between. So -3 minus 1 on top is -4, and 1 minus 0 on the bottom is going to be 1. So we can say -4 to 1 or just simply -4. I think leaving it in that ratio or fraction form is going to help us in this next step though. This increasing line right here I'm going to call line 2, and I'm going to use these 2 points to determine their slope. So -1 minus -2 is -1 plus 2. That's going to give me a result of 1. And 4 minus 0 on the bottom there is going to be 4. So the slope of line 2 is 1 to 4. Positive slope. That makes sense. We got an increasing line. Let's compare their two slopes. We got -4 to 1 compared to 1 to 4. They're opposites, and they seem to be fractions that are flipped, which are reciprocals. So they are indeed perpendicular lines because their slopes are opposite reciprocals. We could even check that last special property, -4 times 1/4 is -1. So the product of their slopes does in fact equal -1. All right, so there's how we determine and prove that two lines are perpendicular or parallel by comparing their slopes. Perpendicular lines have opposite reciprocal slopes. Parallel lines will have equal slopes. Good luck practicing that slope formula and determining whether lines are parallel or perpendicular.